Have you ever stared at a map and felt, well, a little lost? Kinda ironic, right? Well, today we're gonna unlock the secrets of maps. We're gonna see how these incredible documents are so much more than just lines on paper. They're actually a powerful language for understanding and navigating our entire world. So let's dive in.
Okay, so let's kick things off with a little puzzle. Why can't a globe, that perfect round model of the Earth, show you how to get to the corner store? I mean, it seems like it should be the ultimate map, right? But as you're about to see, its perfection is also its biggest problem.
Here's the thing. A globe is fantastic for the big picture stuff. You want to see how continents and oceans relate to each other in their true spherical form? A globe is your best friend. But trying to zoom in on your town, or even just your neighborhood, it just doesn't work. For that kind of detail, we need to flatten the world.
But of course, flattening a sphere is tricky. I want you to imagine drawing something on a rubber ball. Got it? Okay, now in your mind, take some scissors, cut that ball open, and try to lay it perfectly flat on a table. What happens? That drawing you made gets all stretched and warped, right? It gets distorted. That is the exact problem mapmakers face when they try to put our round Earth onto a flat piece of paper.
And that brings us to the hero of our story, the map. A map is basically a drawing of the Earth's surface, or just a small part of it, that's been carefully designed to work on a flat surface. It is the brilliant solution to the globe's biggest limitation.
So, now that we know why we need maps, let's talk about the different kinds you'll run into. Because not all maps are created equal. They come in different flavors, you could say, each with its own job. Let's take a look at the three main types.
First up, you've got physical maps. I like to think of these as nature's own blueprints. They show you the physical landscape, the towering mountains, the deep oceans, the winding rivers, and the vast plains. It's all about the natural stuff, the physical features of our planet.
Next are political maps, and these are probably the ones you've seen most often in school. They show us the world the way humans have chopped it up. Countries, states, cities, all with their neat human-made borders. They tell a story about history, government, and how we organize ourselves. And finally, we have thematic maps. These guys are the specialists. They're built to show you information about one specific theme or topic. A road map? That's a thematic map. A weather map that shows you where it's going to rain? That's one too. Or even a map showing where all the forests are. They tell one very specific story. So here's the cool part. It doesn't matter if you're looking at a physical, political, or thematic map, they all share a common language. And there are three fundamental keys to understanding this language. Once you get these down, you can unlock the story hidden in pretty much any map you find.
And here they are, the big three. The essential components of every single map are distance, direction, and symbols. Think of them as the grammar of map reading. Let's break them down one by one, and we'll start with distance.
So let's think about this. How on earth do you fit an entire continent, let alone the whole world, onto a single sheet of paper? Well, the magic behind that trick is a concept called scale. It's how maps shrink reality down to size while keeping everything in proportion.
So what is scale, really? It's simply the ratio between a distance you measure on the map and the actual distance out there in the real world. You can think of it as the map's official shrink factor.
For example, a map's scale might tell you that 1 centimeter on the paper represents, say, 5 kilometers on the ground. And once you know that rule, you can measure any 2 points on the map and figure out the actual distance between them. It's an incredibly powerful little tool.
Now here's the part that can trip people up, because the names seem backwards. A large-scale map actually shows a small area, like your town or village, but it shows it with a ton of detail. On the flip side, a small-scale map shows a huge area, like an entire continent, but with way less detail. Just remember it this way: large scale means large amounts of detail.
All right, that was distance. Our second key to cracking the map code is direction. I mean, a map isn't much help if you can't tell which way is up, right? To get our bearings, we use what are called the cardinal points.
If you look closely at almost any map, you'll find a little arrow somewhere on it, usually with the letter N at the top. This is the north line. It's your anchor. As soon as you know which way is north, you can figure out every other direction from there. And those other directions are based on the 4 main or cardinal points. We all know them: north, south, east, and west. These are the absolute pillars of navigation on any map. But sometimes you need to be a little more precise. And for that, we have the intermediate directions that sit right between the main ones: northeast,
southeast, southwest, and northwest. Using these, we can pinpoint a location way more accurately.
Okay, so we've covered distance and direction. Our third and final key is symbols. And this is where maps really start speaking their own unique and surprisingly universal language.
I mean, think about it. It's literally impossible to draw a tiny, perfect picture of every single building or road or river on a map. You'd run out of space instantly. So to solve this, map makers use a kind of shorthand. Simple symbols, lines, and colors to stand in for all those real-world features.
And these are what we call conventional symbols. What's so amazing is that through international agreements, many of these symbols mean the same thing all over the world. So that little symbol for a post office or a church, someone in Japan will understand it just as easily as someone in Brazil. It really is a universal language.
Colors are a huge part of this language too, especially on physical maps. It's a pretty simple code. Generally, blue is always for water, brown is for mountains, yellow is for plateaus or higher flat land, and green is for plains. It's a super intuitive system that helps you understand the landscape at a glance.
So, to bring this all together, let's make one last really important distinction: the difference between a map and a sketch. A sketch, like if you're drawing directions for a friend on a napkin, is just a rough drawing from memory. It is not to scale. A map, on the other hand, is always drawn to scale. And that precision, that commitment to scale, is what gives a map its real power.
So in the end, you see, a map isn't just a drawing. It's a shared story about a place, written in a language that anyone, including you, can now learn to read. By understanding distance, direction, and symbols, you have the keys. You can now unlock that story for any place on Earth.